if we look at the probability of disjoint and overlapping events, it helps to kind of look at what is known as sort of like a Venn diagram, where if we kind of combine the two events of A and B happening, some of it may overlap at the intersection. As you can see that both those four dots in the red are a part of the A circle, and those are a part of the B circle. And so this would be called a compound event. Whereas over here, the two circles do not overlap. We would call that a disjoint or a mutually exclusive. So to find the probability of A or B, you must consider what outcomes, if any, are in the intersection of A and B. So again, if we look right here, so there's, if A and B are any two events, then the probability of A or B is the probability of A plus the probability of B and subtracting the probability of A and B. So that's like this example right here. Whereas if A and B are disjointed, then the probability of A or B is just the probability of A plus the probability of B. Again, this had the word or in it, so the probability of A or B. So let's say that a card is randomly selected from a standard deck of 52 cards. What is the probability that it is a 10 or a face card? Well, if I think about how I had my circles, I could have a 10 of spades, a 10 of hearts, a 10 of diamonds, or a 10 of clubs. Whereas face cards, no face cards are ever going to be a 10. So I'm going to draw my circle a little bit bigger. But again, I would have king, 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 queen, 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 jack, 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 jack. So because they're separate, I would be like the probability of A or B would be the probability of A plus the probability of B. And the probability of drawing a 10 is 4 out of 52. And the probability of drawing a face card is 12 out of 52. So this gives me 16 out of 52, which is equal to 4 over 13, which is approximately 0.308. Let's look at this example of a senior class. There are 200 students, 113 are either varsity athletes or on the honor roll. There are 74 students who are varsity and 51 students who are on the honor roll. What is the probability that a randomly selected senior is both a varsity student athlete and on the honor roll? So again, what I'm thinking is our general formula that we just talked about was this yellow one, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. But remember, I want A and B. So this is my goal right here, is to get this by itself. So all I'm going to do is add it over here, and then I'm going to subtract this one. So my new equation is the probability of A and B equals probability of A plus probability of B minus probability of A or B. And now I've got enough information to really go through this. So if I look at it, probability of A is 74 out of 200, probability of B 51 out of 200, and the probability of A or B was 113 over 200. 74 plus 51 gave us 125, which once we simplify this gives us 12 over 200, which is approximately 0.06. So there's a 6% chance that if you randomly selected a student, they would be on the varsity, they'd be a varsity athlete and the honor roll. And in probability, we talk about this idea of a complement. So basically, a complement is like the opposite of what's going to happen. So it's not happening. So say, for example, I wanted to find the probability of rolling a 5 on a dice. So again, the probability of rolling a 5 is 1 out of 6. Well, the complement of that would be 5, 6. The probability of not rolling a 5 would be 5, 6. So again, the probability of an event not happening is what you do is you start with 1 and you subtract the probability of it happening. So again, in the example of the dice roll, there are 6 over 6 possibilities. A 5 is 1 out of 6, which gives us 5, 6. Find probabilities of complements. So when two 6-sided dice are rolled, there are 36 possible outcomes. So let's just, again, take a quick look at this. Here's just an example. Again, the 2 different ways that I could show all the different combinations of rolling 2 dice. So let's find the probabilities of complements. So find the probability of the complement that the sum is not 6. And then part B is sum is less than or equal to 9. So the sum is not 6. So what I'm going to do is I'm going to find the times that the sum is 6, and then I'm going to subtract it. So the sum is equal to 6 at 1 and 5, 2 and 4, 3 and 3, 4 and 2, and 5 and 1. So that gives me a total of 5 out of 36. So that's going to give me 31 out of 36, which is about a 0.861%, or 0.861, 86.1% chance. Now, if we look at the second part, the sum is less than or equal to 9. Again, this time I'm looking for numbers that are greater than 9. So what's the probability of a sum being greater than 9? So we would say, all right, let's see here. That would be 5 and 5 would give me 10. 5 and 6 and 4 would give me 10. 5 and 6, 6 and 6, 6 and 5, and 6 and 4. So 1, 2, 3, 4, 5, 6. So if I take 36 out of 36 and I subtract 6 out of 36, I'm going to get 30 out of 36, which is about 5, 6. 0.833%. So slightly less than our last example. Last example, a restaurant gives a free fortune cookie to every guest. The restaurant claims there are 500 different messages hidden inside the fortune cookies. What is the probability that a group of 5 people receive at least 2 different messages? Or, excuse me, at least 2 fortune cookies that are the same. We'll add the words at least. The number of ways to give the messages to 5 people. So again, the total is 500 to the 5th power. But the number of ways to give 5 different messages is 500 times 499 times 498 times 497 times 496. So the probability that at least 2 people have the same message is that we are going to take what we started with, which is 1, and we're going to subtract the probability that none of them are the same. So we're going to say, all right, well, the probability that none of them are the same is this really large number. Again, we're probably going to use our calculator, and that's going to be divided by the total number of possibilities. And so when I go through and I do all this multiplying on the top and I divide it by 500 to the 5th power on the bottom, I'm going to get 0.0199. So if there are 500 different messages and you're a group of 5 people go into the store, there is a 1.99% chance that at least 2 of you are going to have the same message. Complements, again, to recap, complements are the nots or the opposites. So I can take my total odds, which are always 100%, subtract subtract what it is to happen, what the odds are for it to happen, and then whatever's left over is the probability that it does not happen.